Right, we're carrying on with this. Let me just go to the top. Right, here we are. Half-life is the time taken for the activity of a substance to halve. The unit of activity is the becquerel. Beta decay is the loss of an electron. How does that happen? The neutron splits into proton and electron. Alpha particles are helium nuclei. Beta particles are electrons. Gamma radiation is an electromagnetic wave. It's not a particle. It's got no charge, no mass. Alpha is absorbed or stopped by paper. Beta is stopped or absorbed by aluminium, an aluminium sheet. And gamma rays are absorbed or stopped by a thick lead sheet. Fission, splitting of a nucleus. Fusion is the joining of two nuclei. When you see the fusion of two flavors, that's how I remember it. Irradiation is when food is exposed to radiation to sterilize it. Irradiation is when something is exposed to radiation. It doesn't have to be food. So I can be irradiated by breathing in radon gas. That's something I figured out from the other questions. So it's important to do past question papers and engage with the mark scheme. Right, let's go to the question. Right. Name a fuel used in the reactor for nuclear power station. We know uranium. Or we can put in plutonium. Okay. These sentences describe the process of nuclear fission. Remember, fission is the splitting up. Fusion is the joining. Right, a nucleus absorbs a neutron. The nucleus formed splits because it is unstable. The nucleus splits into two small nuclei called daughter nuclei, and 2 or 3 neutrons. The energy released is transferred to the kinetic energy store of fission products, and then they go and they heat up stuff, don't they? They generate heat, which then is used to heat water, which then is used to turn water into gas, which is then used to turn a turbine, electrical turbine, which then generates electricity. Let's keep moving on. The next question, we said part B because part A was not quite radiation. Right, okay. Radium-226 is this here. That there is the number of protons. That there is number of protons plus neutrons. Right, how do you work out number of neutrons? It's 226 take away 88. How many neutrons are there in the nucleus? It's not 88. 226. You don't add them, so it won't be that. So the only thing that I can say is 138 without working that out. That's being lazy. But you'll have a calculator. Use it. Teacher investigates the type of radiation emitted from a source. Give the name of specific piece of equipment that detects ionizing radiation. Geiger-Müller tube. Geiger-Müller tube. It's a Gigi. How do you spell Gigi? Geiger-Müller tube. There you go. Teacher finds that the radiation emitted is not detected when the detector is more than 5 centimeters away. That means it's going to be an alpha particle because they don't travel far. They don't travel far, but they are very ionizing. Right. What is half-life? Half-life is, what did we say? The time taken for the radioactivity to halve. Radioactivity contains that many atoms, approximately how many? So 1600 years, okay? So 1600 years it halves, but they've only used 800 years. So 1600 years, you're gonna lose, so 2.66 times 10 to the 21. If it was a half-life, it would end up as 1.33 times 10 to the 21. Right, so we're gonna only lose a quarter. What will remain? Okay, careful. What will remain? So if they've asked you for what is going to remain, it will be 1.88, not 1.33. 1.33 would be if you lost half. 2.66, that means there's no decay. 0.67 where it's just totally gone mad. That's double. That's the second cycle of the decay. So that's the only valid one, where you've lost a quarter, not half, because it's only 800 years. Let's move on. Okay, uranium-235 captures neutrons and undergoes nuclear fission. Fission is splitting up, fusion is joining. Right, uranium plus, that is a neutron. It breaks it down into this, and so many neutrons. Calculate X. So look, we've got 235 plus 1 is 236. So we need this to be 236. So 97 plus 135. Okay, let's do that. 132. So this has to be 4. Right, that's it, 4. That's how I did it. What is, chain reaction? I've not come across this one. So let's try to do this, yeah. This is when a neutron is released during fission. When the nucleus splits up, you release a neutron. This neutron hits, and they've put can be captured by other uranium. Yeah, it's uranium. We'll stick to uranium nuclei. And these then split, or they've said, or undergo fission. Remember we said fission equals splitting of nuclei, and fusion is the joining. Okay, let's keep going. Iodine 129 is an isotope, has a half-life of 15 million years. The activity is 72 K becquerel, kilobecquerel. Right, so what they're saying is 72,123 becquerel. So how long will it take? So from there to there, half of that is 36,000. So it's taken 15 million years. Half of 36 is 18. That's taken another 15 mil years. Half of that is 9. That's another 15 mil. Half of that is 4.5 mil. No, 4.5 K mil. That's another 15 mil. So if you add these 15 mils, 15 and 15, 30, 15, 30, 30 and 30 is 60. So we've shown that it's taken that. Right, we've halved it. So really what I should do is divide by 2 just to make it clear for the examiner. So we've got 4 half-lives. 1, 2, 3, 4. We've shown that. There you go. Right. Some radioactive waste from nuclear power station has a very long half-life. Discuss precautions that must be taken. Oh, right. It's a very long half-life. So containers must be strong. Must be strong and made of material that does not rust. What are the problems? These containers and hence what's the word? Disposal is expensive. These containers will have to be made out of a really good stainless steel. These containers will be expensive. Right? You need a secure site. That means somebody has to be there all the time. Right, and it may also leak. This is fine and well doing it for 100 years or 50 years, but what's going to happen in 200 years? The people living in that area are going to end up with contaminated water. It may also leak into the environment, such as drinking water. Okay, so one of the problems, they must be very strong, rust proof, because you're gonna thousands of years. So interesting why they continue that. Oh, guess what? It's finished. So let's go back and finish it off like this. Half-life. What is half-life? It is the time taken for the activity of a substance to halve. The becquerel is the unit of radioactivity. Beta decay is the loss of an electron. A neutron that splits into a proton and electron. The electron then disappears. Alpha particles are helium nuclei. Beta particles are electrons. Gamma rays are electromagnetic waves or electromagnetic radiation. Alpha particles are stopped by paper, beta particles are stopped by aluminium. That means alpha particles are also stopped by aluminium, and gamma rays or gamma waves or gamma radiation is stopped by a thick piece of lead. Fission, splitting up of a nucleus. Fusion, the joining up of nuclei. Irradiation is when food or something is exposed to radiation. And in case of food, it's there normally to sterilize it, to kill bugs. Okay. Alpha particles are stopped by the skin. Natural sources of radiation are the sun, radioactive rocks, radon gas. Right, okay, call it quits there. That is done. I am really happy. Thank you.